way they should be. You see PowerPoint,
I do.
and if I tab over a bunch, you see SQL.
Yes, I do.
All right, beautiful. Just making sure. All right, perfect. That's all I wanted. So if you're ready, I can jump on in.
Yep,
Okay
you're
then.
good to go. Yes, you're all
All
good to
right.
go.
Well, thank you very much for having me. I was just saying earlier before we all started that I haven't really been to Toronto in a while. It's an awkward distance where driving there is kind of far and flying there isn't that far. But I miss it. And so I want an excuse to go out there, which means that if you plan an event like a SQL Saturday and tell me when it is, I'd love to come out there. So just, hint, hint, nudge, nudge, plan an event. I'll be there. But anyway, what I did come here to talk about today was SQL injection and security a little bit more in general. Security is one of those funny things where every organization tells everyone they have great security, but and they might even mean it, but it's not usually very true. Security is a really hard thing to do well, and there's so many ways that it can go wrong. So we're going to focus a lot on SQL today and how that can lead to security problems. But I'm also going to hit on a lot of tangential areas that affect it and that it affects, because it's more than just dynamic SQL. If that's what you think SQL injection is, strap in. We get a lot to talk about. So this is who I am. I'm a data platform MVP with Microsoft. I have published a bunch of books. I write articles pretty regularly. I organize a lot of events. I need to actually update this because SQL Saturday Albany, as of last week, is happening again on August 3rd. Finally, we haven't had one in person since 2019, and we haven't had one in general since we had everyone went virtual panic of 2020. So I miss it. So if you're able to make it to Albany the weekend of August 3rd, please do. It's a free event and everything's up. The call for speakers, sponsors, attendees, everything. So anyway, I'm out there. I speak at a lot of events. I enjoy talking about data, learning about data, playing with data, breaking data. That is what I do. So with that, let's dive right on in. And again, if anybody here has any questions today, feel free to unmute and just ask. I don't think I'll really be watching well, I watch the chat during it. I could try to watch the chat a little bit, but it'll probably be awkward. So I do have the chat open, but you're free to unmute if you have a question and ask, and that's fine. I'll try to keep a third eye on the chat though. So here's what we're going to do. I'm going to do a quick intro to SQL injection. I have a lot of random demos today. I hope they don't break. And a variety of ways along the way to detect, prevent, and consider when it comes to SQL injection and what it is and what we can do. So lots of demos, lots of fun, and I hope we all learned something today. I've learned something in writing this, so hopefully we all enjoy it. And we'll have time at the end for questions as well, if you don't ask your questions along the way. So what is SQL injection? It's a worthwhile question to ask. I think a lot of people think they know the answer. ChatGPT thinks it knows the answer, but I'm always surprised at how bad the answers I get back from ChatGPT are. We can ask it later on if you have a free minute and see what it says, get a chuckle out of it. Injection in general is manipulating any inputs to get unintended code in an app. That's it. So injection is a general exploit. It's a huge exploit. It's not just SQL injection, because you can get code into an app without using SQL. You can do it through all sorts of different means. It's not new. It's been around for decades and decades and decades. That's all injection is. Injection is getting code where it shouldn't be in an app and doing things you're not supposed to do. SQL injection is just the same exact thing, but you use SQL code to do it. So it's actually more complicated and more involved than injection in general. Um, but it's just how do you get the app to execute SQL that it's not supposed to execute? That's what SQL injection is. Many people think SQL injection is dynamic SQL, and it can be. We'll demo some of that, but it's a lot more than that. And if you think SQL injection is only dynamic SQL, you'll get tripped up at some point in the future because there's many other ways. And I've seen production applications get broken by SQL injection that had nothing to do with dynamic SQL at all. So it definitely happens all the time. People often neglect it because it's not the thing you look for first. This was for years and years and years the #1 security exploit. It was dethroned like 2.5 years ago by a few other ones. Despite the fact that it was dethroned by these, it wasn't dethroned because it became less prevalent. It got dethroned because the other ones became more prevalent. This is still a huge problem. It's still getting worse. The instances of it are still increasing over time. So this is a real problem. It's not going away. And I suspect as long as SQL exists, which will be like a long time. There have been a lot of people predicting it's going to go away. No one's going to use SQL anymore. Why would we use SQL when we have low code, no code, blah, 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 blah. It still exists. Everyone uses it, and new apps constantly find ways to use SQL. So it's not going anywhere, and therefore SQL injection is not going anywhere. What makes SQL injection successful? If a user can access or basically do anything on a SQL server that you don't want them to do, and they're not supposed to be able to do, they've hacked you through SQL injection. And it may not be hacking. We always think of hacking as I put on my hoodie in a dark room and I go on my computer and I type really fast and stuff happens. That's not what a lot of hacking is like. A lot of hacking is not like that. People mucking around with URLs and strings and form inputs and calling up your support line to try to scare your support people, saying they're the VP of sales. That happens all the time. That's what hacking is today. It's way easier, way less risky, and it's more successful. Honestly, me calling up your support line over and over, trying to pretend I'm a VP, way more likely to succeed than me getting into your routers and hacking in. Just statistically, 100 times more likely to succeed because people are far more vulnerable than systems are. So what are some kinds of ways that we can cause injection? One of the oldest ones was simply modifying a URL string. And so you have an app, there's a web address, and I go to your web address and I change it around to try to get somewhere I shouldn't be able to get, or to force a form input or a web input to be something it isn't supposed to be. And it works. A lot of apps guard against it, but not all apps do. And it's worth testing. Can I guess the name of files? Can I guess the name of URLs? Can I change the names of things to get whatever I want? Can I change search strings by a URL? And if I can, you're being the victim of injection. If you have dynamic SQL and I can muck with the dynamic SQL statement at all, change it in any way that it wasn't intended to be, you've been SQL injected. What can I do with free-form text fields? Well, the answer is often a lot. People love free-form text because you can learn anything from people, right? The downside to free-form text is I can put anything I want in there. It's the old joke, a QA engineer walks into a bar. They ordered 5 beers. They ordered 1 beer. They ordered 9999 beers. They ordered -5 beers. They ordered null beers. That's what happens in free-form text. People can put whatever they want in, and if you don't really cleanse your inputs carefully and validate them, then bad stuff can get through. People with internal access, employees, vendors, consultants, they can abuse their access. It happens all the time. And it's hard to detect that and track it because it'll appear like valid access until you catch it. People can try to throw error messages by doing bad things to see, can I get an error message that isn't from the app? Can I social engineer my way in with any combination of what I've said already and just social engineering, emails, texting, phishing, email, phone calls, social media, whatever, LinkedIn, you name it. I remember when I first started my current job, in the first week that I was there, I received 4 different text messages from people claiming to be our CEO, needing things urgently. And I knew better. I wasn't nervous. But you know what? A little teeny piece of me still thought to myself, boy, what if that was the CEO? First week at work, I could be in deep trouble. But, I told them to message me in the app. They never did, of course, and that was the end of that. They reported it. If apps have Easter eggs are hilarious, right? I could put a flight simulator inside of my spreadsheet program. I could put in funny messages, code editors. The number of apps that I've seen in my life that had secret places where you can put SQL queries in and run them as a testing interface is disturbing. If you have things like that in your app, beware and make sure they're either secure or they don't exist, because Easter eggs are something we always ignore because they're not an official part of the code usually. We don't really support it. If your app translates into Klingon but you don't officially support it, that's kind of like tech debt in a way, and it can go bad. Last but not least, something that's often missed in this when we talk about security exploits or performance bombs, and that is, can I do a search in your app in a way that would cause to return so many records, either internally in SQL Server or externally to the app itself, that it would break your app? Like if you have a table with 1 billion rows and I find some way to get the SQL query to return 1 billion rows, your app's going to probably cry when I do that. And so that's a performance bomb. Can I force your app to do things that will break your server performance? It'll end up behaving like a DDoS attack, right? I'll cause denial of service. I'll cause locking and blocking, excessive I/O, high CPU, you name it. Those are performance bombs, and no one ever looks for them. But if you can have them, then that's dangerous. So many of these are not things you would think of when you think of SQL injection, but all of them either are directly related or indirectly related to it and are worth talking about. Why do we care about all this? And at the end of the day, the reason is, do you want a data breach? You can like sing that to the tune of, do you want to build a snowman? You can sing better than I can because I can't really sing at all. If you get me drunk enough, I'll play karaoke with you, but it won't be pretty. So you may not really want that. So just keep me away from the microphone. It's better that way. Anyway, all of these exploits, all the things that can go wrong, all of them can somehow lead to data being lost or given away or stolen. And that's a big deal. This is where things go wrong. We all say we have great security until our data is stolen, and then we're in the news apologizing and saying it wasn't our fault. And here's the 100-page root cause analysis. Look, we know it happened. We're not at fault, right? We figured it. You don't want this. You never want to be on this end of a breach ever. It's your career, it's your livelihood, it's your job, it's your company, it's whatever. You don't want it. So the rest of the session is really going to be about how do we avoid a very embarrassing, time-consuming, stressful, sweat-inducing, nightmare-causing situation. So let's start in the beginning. The simplest way that SQL can be exploited is something like this. I'm using dynamic SQL here. It does not have to be dynamic SQL. If you have a form field and it allows you to put text in, it can make its way back into SQL whether you have dynamic SQL or not. This is very, very simple though, classic. I have a SQL command, I have a search criteria, I'm going to splice it on in, right? Select star from person.person where the first name is equal to search criteria, done. And if I go ahead and I run this and I search for all the people named Edward, I get back 72 results, which is what I wanted, and that's great. And now we can keep doing this days on end and things will work fine. This has happened to me in actual code before. I've been hit by this problem, and you will be one day too if you haven't already. You run into somebody who is Irish or has an apostrophe in their name, and they put their name in, and something unexpected happens. Somebody with the last name O'Brien, for example, puts their name into a search field, and they run their search, and they get something like this. Incorrect syntax near Brian, to which you say, what? I don't have any Brian in my code. But if you've dealt with this before, you know it's probably happening. Somebody with the name O'Brien or Callahan or something did this to you, right? And there we go. We have a problem now. Now, if you're lucky, somebody will receive an error message, contact support, and say, hey, I got an error message. I don't know what happened. Can you please fix it? Thank you. And you'll thank them and send them a pizza for helping you out. That's a bug bounty right here. It really is worth it. But if somebody sees that and maybe they did this intentionally, maybe they're a little more gray hat, black hat than most, they might mess around. For example, they'll say, hey, I got a SQL error back. Cool. What can I do with that? All right, let's put in my search criteria, close the string, and put an or in, like this. Or 1 equals 1, and let the rest of it work itself out. I'm printing the output, by the way, here so you can see it. So obviously this is a bad piece of SQL because I have 3 apostrophes. This is bad SQL. What if I run this one here, where my search criteria is this weird string? Well, I run it and I see that a valid query is executed. I get back all the results in the table. So I didn't get back the users I wanted, I got back the whole table. And I can note that what really happened here was I searched for my search criteria, I put an or in, or 1 equals 1, and then I put an and in, open the string, and let it finish out. I knew there was more query here, and so I just let it finish itself out. That's why I put the and there. This may seem complicated and convoluted, but I guarantee that somebody with any knowledge of hacking or SQL injection, whose hat may be a darker shade of gray, uh, they'll know to do this. It's not that complicated. Somebody will figure it out. They can get worse, though. This isn't the worst thing they can do. They can get a little crazier. They can run any query they want, right? At this point, I could put a semicolon here and then put whatever SQL I want. So once they get to this point, and they know they have access to your SQL engine, they can run queries. Well, now you're starting to get in a little bit of trouble here. This is where you want to start being aware of what's going on. That's an example of SQL injection, the simplest example of SQL injection. Not everything is that simple and easy to catch. And how do you catch that? Test all your inputs, QA. That's how you do it. QA should know to test with funny names, test with nulls, negative ones, whatevers, right? What are the most common causes of SQL injection? And the answer is not just bad code. There's many answers. Very often it's not bad code, but it's old code, legacy code, code from a previous application, a vendor app, things you're not responsible for, things that the developer that was responsible for left years ago. They quit and fled to another country and never came back. Whatever. That's very common the case. Not necessarily your bad code, but it's somebody's weird code. Very often we assume that our app is secure. We don't check for SQL injection because we're confident that our app can cover it. Maybe we use some .NET framework or entity framework or something that provides its own security against SQL injection, therefore we're confident. Or maybe we've had no breaches ever, therefore we're pretty confident. Hear the word confident a lot here, right? Or maybe you're moving fast. You're at a startup and you're moving very, very quickly. You have deadlines to meet, and writing new code is more important than fully testing it out. Everyone here have made an MVP before, a minimum viable product. Whenever I hear that phrase, it makes me shudder because minimum viable product usually means maximum amount of bad code. It really does. So watch out for that kind of stuff. Do you have unsupported old apps out there? SQL injection isn't just your code or my code. It could be your vendor code. It could be your Java code. It can be like code that you use with any app alongside what you have. So think about the apps that you use outside of your SQL engine or your code, your Visual Studio, your .NET, your whatever. What are you using for apps? And are they patched? Are they up to date? This can include web servers, domain authentication, app servers, OSs, hardware, network, firmware. There's a million things out there. If you happen to be in the cloud, a lot of this may not be your problem, which is good. If you're not in the cloud and you're on premises, these are important things to think about. If your apps aren't updated, they could have security holes in them. Importantly, very often we have a layer of security. It's kind of like a wall, and we think it's good enough. A wall of security is like so 1990. It doesn't work anymore. You cannot build a wall that nobody can get over in security. You simply can't. That was the old methodology of security like 30, 40 years ago, was I'll have the biggest firewall on the planet and nobody can hack their way through it. And all the good guys are over here and all the bad ones are over here. That's not how things work anymore. The reality is that apps are complex, there are many components in them, and building a wall around all of them doesn't work. It simply doesn't. If you don't have layered security, you will fail, almost guaranteed. I'm going to point this one out quickly because I alluded to it earlier. In an app, there are two kinds of error messages. Two. There are the error messages that you intend. These are errors that you intentionally throw to the user to tell them they did something wrong. They could be serious, they could be funny, they can be cute. The ones, the cute ones often get people pissed off, like, hey, I was working in your app and I lost all my progress and I got a smiley face. I'm not amused. Well, regardless, these are actually good error messages. When you, as a developer, create custom error messages and make sure that users get custom error messages from your app when bad things happen, and the actual error messages get internalized, that's good. That's what you want. You never want a user to see real error messages, ever. They should never see a web server error. They should never see a .NET error, a SQL error especially, because the moment they see an error, they'll begin thinking, well, that's interesting. Can I coax information out of your system? And what will it take? And if you're negligent enough to have bad error messages in your app that weren't intentional, maybe you'll be more negligent and not notice what I'm doing. Like, for example, something like this. A SQL error gets returned to a user. Now, you might think this is gobbledygook gibberish, but to any hacker, to anybody with any knowledge of SQL injection, this is a hint. This is a hint that you don't catch your error messages. Maybe you have an injectable code that could be exploited. Maybe I could begin trying to query for things or get other kinds of error messages out. Learn what tables there are, what users there are, what passwords there are. This is a big deal. You don't ever want to have error messages that aren't intentional. Before I jump forward, actually, I just want to ask, does anybody have any questions so far? I've done a pretty good high level thus far in what is SQL injection and the basic causes of it. Are there any questions before I dive in further into more causes, more effects, how to prevent it?
Anyone, please feel free to ask the question.
And if you don't have any now, that's cool.
I have a question about
Sure.
returning a message.
Mhm.
So we use begin, try, and catch block. So anything that we capture, we sometimes return the actual store procedure name. Is that good practice or bad?
If you're returning it to the end user, I would call that a bad practice because you're giving them information about your schema and that could potentially be exploited. If you're intentionally throwing the error message, it's better than unintentional. My personal recommendation would be to turn that into a more user-friendly error message and internalize the proc name. So you'll get an error message internally to your error log saying the proc name is sp get user password, right? And the user would never see that. The user may simply see like authentication error 5436. I don't know, whatever. And then 5436 is the PK of an error log table that has the information. I'm not saying go out and change it immediately, but you are exposing unintentionally information about your app and its structure to a user. And that would make me just a little nervous because they now know something about your database they shouldn't really know. It may not be proprietary, but it could border on weird if it actually was like sp get password hash or something like that. It could be awkward. Could be if somebody went on the internet and said, hey, they have a proc called sp get password hash. That could be awkward. So I would say that it's awkward, not terrible, but not great either.
Okay, cool. Thanks.
Sure, no problem. Thanks for asking. Any other questions? And if you think of any in between, feel free to put them in the chat and we can discuss them as we go along. But good question. Good question. How do you identify an error message? I personally found the best way over the years to do it is with an ID number. And so you have an error message that goes to a log somewhere and it has a PK. Give them that number and just say, I got error message 3257936. That means garbage to the user. But when they give it to you, it has meaning if they give it to you. And if they don't give it to you, it's still in your log and you can look at it and make sense of it. All right. So let's say you have SQL injection problems and somebody gets access. They realize that they can get into your database and begin querying it. Well, what can access allow? What can you do? Well, as I showed already, you can modify T-SQL and get more data, less data, different data, sensitive data. Really nothing's stopping you, right? If I'm running a query in your application via SQL, I have whatever the permissions are the app has. And if the app has a lot of permissions, well, I have a lot of permissions. If your app has read permissions, that's still maybe too many permissions. So again, it's very hard to prevent that. But keep in mind that the moment I'm touching your T-SQL, I'm running it as your app user, which may have a lot of permissions. I could add new scripts to create objects, drop objects, create users and logins, modify security, do all kinds of crazy stuff, right? Like I could open transactions and leave them open for fun. I could cause locking and blocking, do anything. Sky's the limit here. I could be peaceful and quiet and just test and do select star from sys.objects, sys.tables, things like that, and probe to find out what's your schema look like? What are the names of all your procs and tables and columns and functions and partitions and things like that? How many rows are in your tables? If I have access to system tables, the sys.tables, I could learn a lot about your schema. How many rows are in your tables? Who has permissions to what? What do I have permissions to? What's the current login name? You name it. Could change passwords and permissions, right? Give myself more permissions maybe, or give somebody else permissions that shouldn't have them, and then exploit that later in the future. Get out quickly, maybe nobody notices, and then I can be nodding to a different username later. If possible, I can maybe get components outside of SQL Server. If you allow XP command shell or extended sort procedures, if I can get to PowerShell or SQL Server agent job steps or SSIS or SSRS or Windows, you get the idea. The moment I can get to other systems, I can do things really far outside of the realm of what I should be able to do. If I can get to network drives, backup drives, it gets scary fast. Companies have actually had all their backups deleted by malicious users, and that's dangerous. Very often, if people really want to be dangerous, they'll create a DDoS intentionally, a denial of service, to act as a decoy. So I will intentionally hammer your website, slow it down, and get all of your operational people focused over there. Well, I'm over here stealing your data. It's a very common tactic. It's not weird. Many large organizations, when they're the victim of a distributed denial of service attack, will immediately have somebody checking for anything else malicious on top of that, because it's a great cover, right? It's a beautiful cover. If you have any bugs, if you have any outdated software, if anything else is out there that is well known, it can be also exploited. So once I'm in and I find out you're running an old version of SQL Server that had a security flaw, it's documented in Microsoft's documentation, and you haven't patched it yet, maybe I can exploit it now because I know you have it. Otherwise, I never would have thought of it. But now I know you have old software. Woohoo! Old software I can exploit. And of course, the classic, I could get rid of your data, drop it, encrypt it, ransom it, etc., etc. This is very common. Your data gets encrypted, and then I tell you, send me a bunch of Bitcoin, or your data's gone forever. Ideally, you have backups, and your backups are safe. You can just go to your backups and tell the hacker to go away. But they're relying on the fact that many organizations don't have reliable backups, or they don't test them, or they panic. Many organizations will panic. Oh, you got my data. I need my data back. I don't want you to steal it. I'll give you whatever you want to go away. But that's dangerous. And if you happen to do business in a place that has, privacy regulations, compliance laws like California, Europe, Australia, Canada, et cetera, you may have to publicly disclose all this stuff anyway. So there may not be a secret, easy way out of it. If you are in a place that has like GDPR or other regulations, and you've tried to sneak around them, you can get fined a lot of money, and that could be the end of your career and the end of a lot of careers. So don't do that if that ever happens. Be straightforward and honest, because the alternative can get you in a lot of trouble. So here's an example of how you can exploit SQL injection. And this is one that does not involve dynamic SQL. This involves import forms. So imagine you have a website or an app, and there's a form I can fill out with free form text. I can put a name in, kind of like earlier. And notice, no dynamic SQL. I simply have a search criteria, and I have a query that does a like on it, just like this. It can be passed in as a variable, a parameter, whatever, table valued something, it doesn't matter. It gets into your app, gets into your database, and it's searched for. Now note, I have no cleansing here at all. This goes right on into the table directly with no filtering, no query, no adjustments, no cleanup. Let's say that I, for fun, do this. I put %THO%. Well, when I ran the query before, I got, up here, 85 results. All the Thomases, got them all back. Cool. Let's say I now search for this. I'm not doing anything bad as a user. I'm not actually hacking. I'm simply putting in wildcards into your form field. And if I do this, I get back more things than I should, like Anthony or Jonathan. Things that I should not have been able to search for, probably, because I shouldn't be able to put a wildcard in there. Now, let's say I get cheeky and I say, hey, what if I just put in % into your search box? I do that, I get 20,000 results back. Well, that's scary. I just got your entire table of users back in a single query, and I did not do anything hacky at all. This is not hacking. Is this illegal? Barely. I mean, you might get in trouble for doing this, maybe. But you'd have a pretty hard time proving that I'm being malicious here, because all I'm doing is putting stuff into your web form and getting data back. And you, as a company or organization, will probably never catch this. Unlikely. Unless you had a performance problem that resulted from this and you caught it later. The moral here is, unless you want me to do this, I should not be able to do that. Similarly, I could put regex in, right? I can go down the regex like crazy and be like, hey, I can put fancy code in. Look at me, I'm fancy, I know regex. I can get the whole thing this way too. And again, you probably don't want people doing this. And so either your application or your web form or your database query or store procedure has to have some cleansing involved to ensure that whatever's going in is valid in what you want. And that if this is not supposed to happen, you shouldn't allow this to happen. Ideally, you'd have security on multiple levels, you have cleansing on multiple levels. What else can we do? Let's say we have a login form. This is classic, right? I got a username and a password. And so I go into a web form, I put in username, I put in a password, magic happens, it gets matched to a table somewhere, and then it comes back and either logs me in or it doesn't. Now, maybe I know my password, maybe I don't. So let's say that the query is something like this, and a user ID gets passed in via my login name, and then a password gets thrown in. And let's say I have no idea what the password is. I try 1, 2, 3, 4, 5. It doesn't work. Of course it doesn't work. That's not the password for this random ID. I guessed I was wrong. Now I don't want to get locked out. That would be lame. But the nice thing about guessing passwords and usernames is I don't have to get locked out, right? I can just guess a different username and a different username. And I could even lock them all out. I saw one attack years ago where somebody got the entire email list for a company, assumed that all the email address prefixes were the login names to their application, and they brute force tried to log in using every single login name 5 to 10 times, and every single user, including the admins, got locked out. Everybody. Everyone using an application got logged out and locked. Hilarious, right? Hilarious. I mean, that's, again, it's barely hacking. I didn't like break into your system. I simply went to a login page, began pumping in login names that were maybe legitimate, and that caused havoc. A whole day of havoc and panic. So, all right, I got nothing back from this query. Let's say I mess around here and try something creative. I put in for the password, quote, quote, space, union all, select star from person.password where, open up my query and start over. Again, this may sound like something outlandish nobody would ever do, but guess what? A password table, a user table, a login table, a password hash table, those names aren't that uncommon. They're pretty common. In fact, most companies have a table called person, employee, password hash, credentials, and stuff like that. Like, I guarantee that 3/4 of all organizations have a table with a name kind of like that, or more. So this is not outlandish at all. I go in here and I guess, and I run this query. What do I get back? I ran a query. I closed it. I said, search for the password hash equals quote, quote, which returns nothing. But then I union all, select star from person.password, where whatever, whatever. Open it back up. And the result was the entire person.password table. Now, will this let them hack everybody? No. But I did get a whole bunch of information I wasn't supposed to get. And I know I can get more information by injecting more SQL into here. This can be replaced with whatever I want now. sys.table, sys.column, sys.logins, you name it. So sky's the limit here. I could similarly put in a password that I don't care about and then simply close the string, right? And it won't care because I commented it out. Slick, right? Select star from person.password where the ID is 3 and password hash equals password. But I put right after that login name, I put in comment. And I hoped that all the SQL is on one line. And I was correct. Well, what if it isn't? I could still do this, right? I could put this in my username and this in my password. And again, this all sounds outlandish and crazy, but there's enough different exploits here that all I need is one of these to work. Just one. All I've got to do is guess one syntax that you let me get away with, and I'm in. I can do whatever I want to your system. Sky's the limit. Ed has control. Woohoo! It's a party, right? I showed some really crazy SQL here. Does anybody have any questions? This was not all dynamic SQL either. Some of this was simply me mucking around with search criteria.
Edward, I have a question.
Sure.
I understand, like, when there is a public facing but application, most of the cases the hacker will come through that way. How about the internal application that we build? Do you see that also have some kind of risk?
I find that in smaller organizations, the risk is less, but it's there. The bigger the organization, the more internal people you have but don't know, and the more chance there is that you have employees that left, but maybe you didn't terminate them correctly, or maybe you have contractors, or just again, people you may not know very well. And they could do things like this. If I'm an internal employee, I have a lot of like privileged knowledge about your system. I may know ways to do these sorts of things that other people don't know. So there's definitely value in ensuring that all of your internal resources don't have more permissions than they should, and that your application doesn't have more privileges than it should. And we'll talk about that more later.
Oh, sure.
Principal
Thank you.
keys privilege. But you're 100% correct. Can internal users take advantage of you? Yes. And the bigger the organization is, the more risk there is. But that risk is always there because a small organization might be careless because they're small, and a bigger one simply has too many people. Keeping track of them all is hard.
Thank
Great
you.
question. Great question. Let's jump back. Here's the most common answer to SQL injection. I say we have a SQL injection problem, and then somebody says, we'll write better code. And that is an answer to the problem. It is also a cop-out and not the best answer. Why? Because SQL injection and security exploits are caused by a lot of things besides simply bad code. We can all do the best we can to have great code review and go out of our way to make sure that we validate and review and rewrite and do everything we can, but we simply can't control every line of code. And you simply may have source control. You may have all of your pull requests and your merge requests and your like code reviews and things like that. Whether you have those things or not, it won't catch everything. Here's a classic example. Let's say you're a code reviewer. You may or may not be. One day you might be. Let's say somebody sends over a script for you to review that is one line of code. You'll look at that and read it carefully, right? And you'll say, one line of SQL, I'm going to read that carefully and I'm going to perfect it. If there's a single little issue there, if your comment is misspelled, if you capitalize the wrong, I'm going to let you know, right? Let's say I send in a script for review that has 10,000 lines of code. Are you really going to review all 10,000 lines perfectly? If you're very diligent and really impressive and have a lot of free time, which not everyone does, it's not something everybody can do, you may actually review 10,000 lines of code carefully. But guess what? Most people won't. End of the day, we don't have time to perfectly review and rewrite everything. We can't control every line of code that goes into the app. We also can't control legacy code. If you're a company that merged with other companies or bought other companies or was bought by other companies, you can't control it all. You can't control vendor code or platform code or other app code. You simply can't control every line of code. And because we're human, we're going to make mistakes occasionally, guaranteed. And so saying we're going to write better code is good, but it's not a complete answer and it's a cop-out because the moment you say that, we neglect the rest of this presentation. And that's a huge security risk. You're turning a blind eye to other things that can go wrong that are very serious. So do not fall prey to this. You can write better code and you should write better code. We should all write better code. I have bad code I've written. We all do. And that's cool. It's life. We're human. But things evolve and change and we can't catch it all. So Assume this is only part of the solution and not all of it. The best way to look at security is like an onion, not a wall, an onion. Security is like Swiss cheese. It really is. You have many apps, many microservices, many things that you do and have and maintain, and you can't secure them all in one layer. You should have many, many layers. For example, you have a web form. Your application should immediately upon that text being entered in the web form, it should be validated. It should be checked, QA'd, and ensured that it's correct. Invalid characters are pulled out, blanks are dealt with, apostrophes, whatever. You cleanse your input. But then maybe the app server internally or the framework checks it as well. Maybe SQL, if necessary, in a proc, validates it as well. This way, you have an onion. You have many layers, and each layer checks each other layer. Therefore, if you have a security flaw here, it gets caught here, and no one ever knows and has to deal with it. We assume we have security flaws somewhere, maybe minor, maybe not. But if other layers of security catch them and prevent them, then you're good. You're far better than if you had no layers of security. Yes, security is like ogres, like onions. They have layers. How do we defend against SQL injection? There are many ways, many, many ways. I can go on all night, but I'll provide some of the biggest ways, the most significant ways that we can defend against SQL injection. Number one is sanitize inputs. If you have free-form inputs, beware. That is where most bad things come from in applications, is free-form input. If you let me type stuff in, I will type stuff in. You may say, I never intended for the user to put that in. It doesn't matter. If I can do it and you let me do it, it's your fault, not mine. I'm the dumb user. You're the coder. You're supposed to know better. So assume that the user will put anything in. Anything. Weird stuff, empty strings, apostrophes, nulls, wildcards, whatever. Just assume it. A great way to cut that loss is to simply minimize the use of user-generated input. Free-form fields are great for some things, like when you're creating a user for the first time, you need a username and a password and a first name and a last name or whatever. But once you've gotten past that, you may not need any more. For example, should I be able to put my date of birth in manually, or should it come from a dropdown? A dropdown is way safer. I can't hack a dropdown very easily, right? If I have to pick my birthday from there, I'm forced to pick a number between 1 and 12 and 1 and 31 and a month and a year between, I don't know, 1900 and now, right? And that's it. And I can't put anything else in. So minimize user-generated input because the less of that occurs, the easier it is. For example, there are many surveys out there that try to collect information, they get trolled, right? What's your religion? Jedi. What's your occupation? Jedi Master, Sith Lord. Like anybody can do that. What's to stop you, right? And so whenever you don't need free-form text and user-generated input, don't use it. It's not worth it. Avoid it at all costs. There's no harm in having a drop down. It's not hard. And you can always add more things later. Even the user can even add more options later in some admin area. That limits who can do it, right? If gender is a drop down, people can add more genders, no big deal. Whatever. You can have 2, 3, 5, 10, however many you need for your organization to function. But if I can put it in manually all the time, I can put anything I wanted, including bad stuff, including hack stuff. So, don't let me do that. Try to avoid dynamic SQL where you don't need it. Dynamic SQL is a wonderful solution for maintenance solutions, internal processes, and for some searching solutions. But don't use it everywhere. It's like a tool, and use it where the tool makes sense. Don't use it everywhere. I have presentations on dynamic SQL, and I have a book written on it. It's a great tool, but use it where it makes sense. And if you do use it for anything user-facing, make sure the inputs get sanitized carefully so nobody can abuse it. Make sure if you have any apps or tools that you rely on for anything, internal, external, whatever, that they're up to date. They're patched. Patching is important because the longer things go without being patched, the more opportunity there's for security exploits. And that's just not something you want. If you have error messages, make sure that you generate them and hand them off. Do never let framework errors or SQL errors or .NET errors or whatever. Never let internal errors get out. Only have app-generated errors, even cute ones, whatever. I don't care. Just don't have errors that can be exposed and give information that users shouldn't have. If you have stored procedures, parameterize them. Don't splice in inputs like I did earlier. Have parameters, and parameters can help ensure that your queries get more guarded against SQL injection. If I use SP execute SQL and I have parameters going in, it's harder to exploit that than if I simply splice in inputs. So always parameterize anything you use. There's more. I have more. I have tons. I can go on all day. If you have a result set being returned from SQL to a user, use top. Have a top and have an order by. Why? Because how many results does a user actually care about in a form or in an app? And the answer is maybe 10, maybe 100, probably not a million. I'm never going to scroll through a million results. I may need to know there's a million results and I should refine my search, but you don't have to return all million results to me. And so whenever you're returning a data set to a user, have a top, have a offset. Never return the whole data set. This will prevent performance bombs, and it's just a nice way to ensure that I don't see more data than I should. If I try to hack you and see too much data, you just limited my ability to do it. Validate data. Anywhere data comes in from an outside source, validate it. How big is it? What characters are in it? Is it cleansed or not? Check it all. Make sure it's valid. Don't assume anywhere in your app that the data is fine because somewhere else made it fine. Make sure you have onion security. Make sure every layer of your application, from the app itself to your network, software, hardware, the database, your web page, app, whatever, make sure that it has security. If every single layer of your app has security, I've got to work really hard as a hacker to get in. That's a big deal. And ensure that you remember that included in that are things like backups, vendor software, logging, and security-related applications. Very often we forget those things exist. We have some third-party software that runs backups. Backups always work. Nobody cares about them. I delegated them to some junior who, gets drunk every Friday night. I don't know. But never assume that any of your software shouldn't be checked for these problems. If you do security or pen testing, include all these things as well. And if your vendor software is insecure, contact your vendor and threaten them because that shouldn't happen. If you use XP command shell or extended stored procedures, make sure their use is limited and not user facing. So if a user can get access to those through any security possible, they can do a lot of things they shouldn't be able to do, like get to the OS, get to the file system, get to your backups, get to PowerShell, I don't know, get to other servers, network paths, and you don't want that. Make sure that application logins only access what they need. Don't let them access the agent or PowerShell or SSIS or SSRS, files, networks, whatever. Your application logins should only get to application stuff. And then service logins can get to other things. Separate them though. You gotta keep them separated. An old line from a song, right? But keep them separated because you don't want users having access to that kind of stuff. And if you can, have monitoring that checks for suspicious activities because you can monitor app logs, web requests, API logs, web traffic. You don't have to monitor it manually. Just have searches against them. Have something that crunches that data every day, every hour, whatever, and see, is somebody trying to SQL inject? These are common security processes. There's lots of presentations and articles out there on it, but monitoring for this stuff is valuable, and it gives you a bit of mitigation. If you do have a security problem and you don't know about it, this will help you catch it after the fact, but maybe before too much damage is done. And maybe before any damage is done, which is good. If you find a vulnerability and you catch it and nothing bad ever happened, you can breathe a sigh of relief and maybe nothing bad ever comes of it. I alluded to this earlier. Principle of least privilege is really, really important. Any SQL Server account that you have should only have access to what is needed. Very often when we first create an application, what do? We make the user DB owner and the login sysadmin. Don't do that. If you have an application login that the app is running under, give it whatever permissions it needs to a database. Maybe read and write. Maybe that's it. Maybe it needs a little bit of DDL or some temp DB access, maybe, but limit it. Be in charge of it. ensure that it can't write the things it shouldn't be able to write to, it can't run things it shouldn't be able to run, or do things it shouldn't be able to do, and you've removed a lot of the exposure to security threats. Never use sysadmin unless you're actually supposed to be a sysadmin, which should be a very small list of people. Don't use DB owner except for somebody that should actually be a DB owner, which honestly, if you're a sysadmin, you don't need DB owner because you're already sysadmin. So what needs DB owner? Not much. And if a vendor software or application asks for sysadmin or DB owner, either say no or sandbox them. Give them their own private isolated server and keep them off your network, because why do they have all that stuff? Don't use SA. SA is an automatic sysadmin that you don't have to use. When you first create a SQL server, set a wild password, disable the login, and never use it, ever. SA is, everyone knows it's there. You can't drop it easily or get rid of it, and people will try to hack it. If SA is an active login and that password is guessable, it might get guessed. If it's not guessable, they might lock you out of it. And then when you rely on it, you're screwed. So don't use SA at all. And don't have accounts with obviously silly names like admin or administrator if you can help it, because people will guess that. They'll guess it. If you have different apps and users and processes and things like that, use different roles and different logins, maybe different schemas. If you have 4 apps in the same server, they don't have to all have sysadmin or DB owner. They don't have to all share a login. In fact, they shouldn't share a login. If they all have different logins, you can monitor their activity separately and know what they're doing separately and know which of them is responsible for a problem or a security problem or a performance problem or whatever. If you have the choice between Windows Auth and SQL Server Auth, use Windows Auth. It is more secure. It is harder to hack. If you have to use SQL Auth for many reasons, can't always avoid it, make sure the passwords are really, really secure and the login names aren't too easily guessable. If all your logins are easily guessable, like it's my email address, somebody might guess it and try to hack it. And eventually they'll succeed because somebody will have a dumb password, because that's what'll happen. And if you have password requirements, I'll find a way around them. Oh, I can't use Lego 123. I'll use Lego 123 exclamation mark. Oh, let me put a number after that. Okay, I'm good. Somebody will do that eventually, and it's still guessable. It is. It is. Before I go on, does anybody have any questions before we begin to approach some demos and the end of this? I know we have till 7:15. I want to make sure anybody has any questions, though. They can ask them along the way before we forget our questions. Does anybody have any questions about anything presented thus far? SQL injection, security, scary stuff. Okay, it's cool. It's always worth asking. All right. So how do we prevent SQL injection? There's many ways in an app to do it, and many ways in a app, web page, so on and so forth to do it. But how about in SQL? Within SQL itself, there are many things we can do that will each help. The first and simplest thing is to use SP-execute SQL. This is a very, very easy thing to do. If you have dynamic SQL, or if you simply use exec right now in your code, change it to use SP-execute SQL. And the primary reason is you can parameterize. I can have my SQL command, I can have a parameter list, and then I can have my search criteria. And when I run this code here, I can search for my search criteria, Clark, whatever, and it works great. But the beauty of this is I can't cheat. I can't mess it up by accident. If I put in O'Brien as my name, it still works because it's parameterized. So O'Brien gets passed in through my search criteria into here and stored in a variable. It's not literal text being spliced into a query. It's just a parameter value. And so I don't have problems. I can search for whatever I want here. I can try to do scary stuff like this earlier. I showed out earlier I got access to person.password. If I try that here, I get nothing back. Now, oops, sorry about that. I get nothing. Now note, I did get back O'Brien up here. So O'Brien did return an O'Brien the way it should. But my attempt to hack here with union all and closing a string returned nothing, because guess what? There are no users named that. Done. So by parameterizing my SQL, I've solved many problems that can occur already, whether it be through dynamic SQL or simply a stored procedure. Just parameterize and many problems go away because now your variables become parameters and you don't have any weird stringy stuff going on that could otherwise go on. One biggie is to cleanse inputs. If you know that you have inputs coming into SQL and there's a chance they may not be cleansed, you can further cleanse them. There's no downside to doing this. There's no downside. The worst case, you cleanse an input twice and it's extra clean. Whatever. You washed your hands twice instead of once. Whatever. No big deal. No harm done. It won't break anything. Obviously, you can do something like this. I can have an input string and I can do a bunch of replaces. This works. It's kind of funky because it is going to potentially miss things, but this is better than nothing, to be honest, and it does work. So if I were to go ahead and make a, this is a good idea, not really, but it works. I can see that I did strip out all the characters. If you really know all the characters that you want to strip out, you can do this. The downside is you'll probably miss something. New line, end of line, tab, weird extended ASCII characters. You're probably going to miss some. So the replace solution is better than nothing, but it's a false sense of security and I'll probably miss stuff. What's better is make a function. Make a function that will cleanse a string. You pass in an input string, and you put in the characters that you want to keep, or discard, I suppose. And then you go and you clean it up. It can be done through, and there's many ways to do it. I use a while loop here. If performance matters to you, you can do it through a CTE or something else. Again, I'm just demoing how to do it. I'm not optimizing it here because it may or may not matter. So I'm going to go ahead and if it exists, I'm going to drop this thing. I'm going to create it and then use it. And all it's going to do is just choose the characters I'm going to keep and discard the rest. That's all. I'm going to go ahead and just remove all the stuff I don't want. If I go ahead and run this first one here, this is a test and all the funny characters removed. Here I tried to put in wildcards and apostrophes, and again, didn't work. All the junk got removed. See? Just like that. So no big deal. The beauty of relying on a function is I can reuse it, which is nice, and I have one central place to modify it in case I change my mind in the future and say that I do want underscores maybe, or I do want dashes or ampersand. That's okay. And so you can customize it in one place and use it everywhere. If you're using object names for any reason in dynamic SQL, which is very risky, always put in the schema name. Don't shortcut it with ... Put in the schema name because the result will be something a little more easy. If I have something like this, select star from schema.table, this is dangerous SQL to start with. I could very easily just throw in person, semicolon, select star from person.password, and guess what? It works because my code is simply flimsy and I got all the contents of the password table, just like that. But what if I simply put in the schema name? So instead of this, I add brackets in. So I simply say same query but put in brackets. The brackets will help, but they won't guarantee success. I could put something bad in and I at least get an error now, which hopefully gets caught by a friendly error message, but it's still not great. And I can still learn that maybe I can still find my way in by mucking with it like this. I can close the bracket, right? Why not? And again, this may seem like something that's very outlandish, but somebody will think of it. The best way to solve this problem is simply to parameterize and call it a day, or input cleanse, or include the brackets and the schema name, and then parameterize. Just the more you can do, the more layers, the better. That's all. Input cleansing is a big deal. Let's say I have a web search proc. It isn't that weird. Many organizations use them. I'm not against them, but be careful. Let's say I go in and I check the search data. If it's null, return blank. Otherwise, strip the stuff out and give me a top 25 done. This looks pretty good. I can search for a PO number and get back the PO number. Woo! I can search for null and get back nothing, which is good. I can try to hack and get back nothing. And so what did I do here? My search proc has a bunch of things. First of all, I parameterize the search data, 1. I check for null, 2. 3, I strip out all the non-alphanumeric characters, right here. And then I put a top in there just in case, to ensure that I don't get performance bombed and return all the results. And I put an order by just in case needed. You should have additional cleansing elsewhere in your app, in your web form, but if you don't, if it gets all the way to here, at least you have something here. And that's good. These are all examples of ways in SQL to improve your security if you need to. You may not have to, but you might. And if you have anything in SQL that hits a user, this is a great way to avoid bad things. So let's run back here. What other things can we do outside of what I've just shown, which basically amounts to writing better code and being careful? What else can we do to make our lives better in the world of security? First off, we have logs. Our world is full of logs. You have web logs, app logs, window logs, the event viewer, SQL Server error logs, and so on and so forth. There's so many places you can either manually or automatically collect log information. you should scour those logs, not by hand necessarily, but automatically. Have some way to go back and check them and verify there aren't bad things. There's no harm. Do security tests, either yourself or through a security company. Have a third-party organization test you. Does that cost money? Yes. But if you have exploits that are exposed to the user, they're probably going to find them and report them back to you. And you would much rather a security company does that than a hacker. Always. What else? Code review. Code review will not catch everything, but assume anybody can make a mistake. Have code review for everybody, even your admins, even your architects, even your VPs. If you can submit code changes, you should submit to code review. No one's above the law. It's that simple. I am subject to code review. When an MVP at Microsoft submit code anywhere, I get code reviewed. And you know what? That's fine. I want that. They'll eventually find something, guaranteed. I've made mistakes in the past year. They've been caught. So we all make mistakes. We all do imperfect things. Or somebody simply may have a question. Hey, Ed, I don't understand the code you wrote. Why did you do that? And I'll answer the question. Maybe it requires some documentation. I don't know. But it's a good thing to have. Have code review. And worst case, have a third-party security firm check your security. Have them help you out. Have them be involved. There's no downside if you have concerns. If you're too small to manage all your own security, have someone else do it for you. That can help you find problems when you can't find them yourself. In addition, time is an important thing on your side. If you do all the things that I said to do here, you've made a hacker's job very difficult. You've made it so that to hack you requires more and more and more and more and more and more time and effort and energy. And the more time they spend, the more risk they incur. They'll get caught. Very often, a hacker will eventually give up. If they try and try and try and try, they will simply give up and move on to an easier target. That is a valuable tool. Honestly, if a hacker really wants to hack you, if they're devoted, if they're 100% committed, they'll spend any amount of money and time and resources to get you, they will probably eventually find a way to piss you off. But if you make it hard enough, they will probably go away. And last but not least, be an onion. Have security in layers. Onions are smelly, but they're tasty, and having layered security will help you a lot because it means that if I get through one layer, I hit more walls. I get through the next wall, I hit another wall, and so on and so forth. This is a great way to deter hackers. And if you do check all of your logs, you may find out that somebody's gotten through a layer, but they're hitting more walls. And so you're still safe. They didn't get in, but you know you have a security problem to patch. And so onion security is very, very important. Security should be like an onion, always. So to kind of wrap up and turn it back to you for questions, SQL injection is, has been, and probably will be a top vulnerability for a long time to come. It's not changed. Everyone is still going to get away from it. We'll find ways away from it. We'll somehow patch it, secure it. It hasn't happened. Instances of SQL injection are higher than ever. The exploits are more than ever. Have been pwned or not, still out there. So Assume that you're at risk and that you should be careful. Have layered security because it avoids a single point of failure. It's kind of like high availability for security. Guard against it. Don't assume that everything you've done already is good enough. Keep an eye out for ways to improve your security and improve it whenever you can. And know that good code isn't enough. It's a good excuse, good code, but it's not enough. Do not assume that super duper code reviewed is going to solve the problem, or training for all your employees on how to write better code is good enough. It's not. Everyone's human. They make mistakes. Doesn't matter if you do it or ChatGPT or Copilot does it, doesn't even matter. Somebody will make a mistake, and that mistake could manifest in a security exploit. So assume that good code is good. It's great. It's awesome, but it's not good enough. And by doing all of this, you don't become a statistic, which is a big deal. Security is all fun and games and laughs until you actually have a breach. And then you're on the line at 1 in the morning, you're tired, you're grumpy, and life stinks. You don't want it to happen to you. I don't want it to happen to me. Nobody wants to happen. So don't allow it. Know that security is a way to lose a job legitimately for a lot of people, for companies to end. I've seen personally firsthand companies go away, organizations be destroyed by bad security, resulting in data deletion, backup dropping, things like that, to the point where an organization couldn't function anymore and they had to give up. It can happen. Don't let it happen. So, thank you very much for letting me be here and talk about SQL injection. This is all of my information. If you need it after the fact, feel free to ask for it. Ask any of the admins for it. Ask on Meetup. I'm a Meetup. I added you on Meetup a while ago, so feel free to just ask me questions on Meetup, and I'll answer them. I don't have a question slide here, so if you have any questions, now's a great time for questions or chat.
So feel free to come off mute if you have any questions. I'm not seeing anything in the chat at the moment. Oh, someone's typing, so we'll just wait for that one. Thank you so much, Ed, for your presentation. That was awesome.
It's a lot of fun. I've not given this in a while, so I revamped it a lot. Hopefully, some of the jokes were a little funny in there. I hope. Got a few laughs out of it. I try, but I'm a dad, so the dad jokes can get bad. But I try. I do try.
No, it was
If anybody has any
really
questions, though, this is a great time to ask. Happy to answer now.
I have a question, Edward, but not related to SQL injection. Are you traveling to Pass Summit this year too?
I'm planning on it. I've not registered
Okay.
quite yet, but I'm planning on going, and I should be there. So I would say 99% chance that I'll be there unless something extremely, crazy comes up. I've been to Past Summit in some form almost every year for like the past 15 years or so. I missed 1 year because it was in person on Halloween, and my
Huh.
kids could not tolerate it being on Halloween. That was a deal breaker. But in general, I love Summit. It's a great event. I hope you can make it. If it's
Yeah, I
too
hope
much
to
money,
see you again like
I would
last
love
year.
to see you there. That'd be
Yeah.
awesome. In the meantime, though, I'm a huge proponent of free training. Check out our SQL Saturday in Albany. Check out other local and regional events or free training. If you add me on LinkedIn or Meetup, I post regularly about free training opportunities, cheap training opportunities, virtual, in person. I'm a huge proponent of free training. It's one of the most valuable things we can do to give back, like this user group. So, thank you for organizing this and having me here, because it's a huge value to the community. Because you're virtual, it's a value to Toronto, it's a value to everywhere. So thank you for doing this.